here comes the last part of our topic, which is diffraction. Okay, so diffraction is the spreading of light waves as it passes through small openings or sharp pointed objects. Unapokuwa unamuita mtu mbali, ukiita Costa, okay, kama mtu uko mbali unaonaga watu wanakunja mikono wanaweka mdomoni hivi, umeona kama ninavyoongea hivi, umesikia ninavyoongea hivi, wanaweka mikono hivi, Costa, tofauti na tukiita tu Costa, Costa, nikiita mbali. Lakini nikiita mtu ambaye tu nimeweka mikono hivi, naita Costa, naweka mikono mdomoni, nimeizungushia kwenye mdomo. It is because we are trying to create an opening ambapo itatengeneza diffraction, the light, the sound will be spreading. Okay, lakini our principle mainly hapa tutadeal na diffraction of light waves. So diffraction generally ni spreading of waves as it passes through small openings and sharp pointed objects. So before we go there, lazima tujifunze the Huygens principle. Huygens alikuwa ni scientist ambapo they like to ask you should state the Huygens principle, so at least katika level ya kustate is enough. Okay, so Mr. Huygens is trying to tell us that every point on a given wavefront acts as a source of secondary wavelets. So we're having a wavefront. Okay, so every point on a given wavefront acts as a source of secondary wavelets. So kunakuwa na a wavelet at every point along the wavefront, every point wavelet. Okay, and the position of the new wavefront at any instant is a surface touching these wavelets tangentially in the forward direction. So you can see the tangent is the wavefront is touching the tangent in the forward direction. So again, another wavefront, kunakuwa na points, so each point is a source of secondary wave. So in the forward direction tangentially inakuwa that way. That's the principle of Huygens. So and I try to explain diffraction inavyotokea. So the more it is going, the more it is spreading na that way. Wavefronts inatengeneza points where the waves can come and it moves on that way. So note that this is just in short. Na huwa wanapenda tu kuuliza illustrate na ukiwaambia the 2 points is very enough. Okay, so note the following. This principle can explain all wave properties except photoelectric effect. Okay, Huygens principle can explain all the wave properties, diffraction, the interference, the reflection, all except the photoelectric effect. They like to ask this question. Kwamba mention one wave property which Huygens principle cannot explain. So it is the photoelectric effect. And again, the wavefront is a continuous location of all particles of a medium which are vibrating in the same phase and moving in the same direction. As you can see, that is called the same phase and the same direction, these points. Okay, continuous location of a point, the continuous location of a point. Okay, diffraction grating is the arrangement of large number of close parallel equidistant series ruled on a glass or metal used for studying spectra. So there is a term called diffraction grating. The definition is there. So ni kazi kwako kuikariri na kuenda kuipaste watakapokuwa wanauliza. They like asking define diffraction grating. It's different from ukiulizwa define diffraction. When you define diffraction, you just define this. When you define diffraction grating, you define what I've written up. So we have two types of diffraction. Tuna Fraunhofer diffraction na Fresnel's diffraction. Okay, Fraunhofer diffraction is when the rays of light before the hole where diffraction we expect to occur inakuja zikiwa in parallel. Okay, zinakuja parallel rays. While for Fresnel's diffraction zinakuwa non-parallel, zinakuja as if they are diverging. They are not parallel, as you can see, they are just diverging. So that's what we call Fresnel's. Nakumbuka kuna nectar ambayo they asked so to differentiate the two, Fraunhofer diffraction and Fresnel's diffraction. Okay, so most of the time we usually use Fraunhofer's diffraction. That's the most common that we use most of the time. So path difference again is coming here. Labda nikwambie tu a point to note. Diffraction is more or less similar na interference. Kama ulielewa interference ya double slit, Young's double slit experiment, diffraction is a complete copy ya Young's double slit experiment. Kwa Young's double slit experiment kilichokuwa kinafanyika ndio exactly the same ambacho kinafanyika kwenye diffraction. Okay? Baadaye tutakuja kuona differences za interference na diffraction because they are more or less similar. Okay, so we will derive our formulas in a different way, lakini tutaona zitakavyokuwa zinafanana na za kwenye Young's double slit. Kuna few details tu ambazo zitaongezeka ambazo kule tulikuwa tuko interested nazo, lakini huku zitakuwa ni za muhimu. Okay, huku zitakuwa ni za muhimu. So assume you have the width. The diagram is small. I want to maximize it ili uone vizuri. You have the width of the opening, which is D. Okay, you have the width of the opening, which is D. So when light is coming, inakuwa deflected. Diffracted. Okay, inakuwa diffracted in various angles. Okay, so our interest is we want to form a certain triangle hapa. Okay, we want to form a certain triangle. This distance is D, and we want to form a certain triangle. Itakuwa in such a way ambapo tutatengeneza 90 degrees hapa, na hapa tutakuwa na angle theta. We are trying to look the path difference. Kumbuka we are having a ray ambao pia huku the angle is theta. Though our interest ni kwenye hako ka triangle. Okay, hako ka triangle. So we know that the path difference ni sawa n times wavelength. So I want to enlarge this ili uone clearly what is going on here. Assume that we have our opening near the distance between the slits ni D. Okay, so assume we have one wave ray inakuja hapo, another ray inakuja huko, so they are diffracted. Okay, they are diffracted. So you can see if we cut this area here, kuanzia hapa mpaka hapa patakuwa sawa na hapa mpaka hapa. So the path difference between this path na that path, okay, this is the path difference, which is n times wavelength. Hicho ndo kilichozidi, ndo difference ya this path na that path, hiki ndo kimezidi. Okay, so we can term this as angle theta. Okay, so if we are having that angle, if we are having this angle ni sawa na tuna hii angle, tuna hypotenuse. Okay, tuna hypotenuse na opposite, so tunatumia sin. Okay, sin theta ni sawa na opposite ambao ni n times wavelength divided by hypotenuse ni D. So inakuwa D sin theta ni sawa na n times wavelength. D sin theta ni sawa na n times wavelength. Okay, so jinsi gani diffraction patterns zinakuwa formed? Kunakuwa na screen huku, sawa, kunakuwa na screen ambao that screen image inakuja kuwa formed huku. So exactly ni kama ya kwenye Young's double slit. Okay, exactly ni kama ya kwenye Young's double slit. So geometrically if this is the center, if this is the center maximum, this is the center maximum, or so a beam that will come straight to touch at that point, okay, itakuwa isingekuwa diffracted, ingenyoka straight ingekuja ku touch that point. So since it is diffracted, inatengeneza with theta. Okay, so geometrically this angle ndio hii angle ambayo ndio maana tulichukua hii angle, tukuchukua hii angle. sawa, tulichukua hii angle huku, sawa, tulichukua hii angle huku ambayo inafanana geometrically na this angle huku. So how is it similar geometrically? Tunaweza tukaona this angle hapa, hii ni 90 degrees. Okay, hii ni 90 degrees. So ukichukua 90 ukatoa theta unapata hii angle hapa. Tuseme hii ni 90 minus theta. Okay? Lakini tena hii angle ni 90, hii angle ni 90 pia. Okay, hii angle ni 90 pia. So angle ya kwanza ni 90 minus theta na hii ni theta. So tukichukua theta plus 90 minus theta tutakuwa tupate ngapi? 90. Okay, tutakuwa tupate 90. So you can see kwamba theta na theta zina cancel, kwa hiyo tunabaki na 90 ni sawa na 90. So that proves kwamba angle ambayo ilikuwa huku ndio hii angle ambayo iko hapa. Okay, kwa sababu ukichukua 90 ukatoa hii hapa unabaki na theta ambayo ndio hii hapa. So that proves kwamba if you take theta plus 90 minus theta ni sawa na 90. Unaona 90 sawa na 90. That means configuration ya hii hapa 90 ndio sawa na configuration iliyokuwa hapa ya 90. Okay? So kama hii ni 90 minus theta and the rest part ilikuwa ni theta. Na ukileta hapa hii ni 90 tena. So kama hapa ni 90 minus theta then hapa ni theta pia, ni kama ilivyokuwa mwanzo. So that proves this angle is sawa na that angle geometrically. So this angle bana ina maajabu yake. Sawa? Kwa sababu ukiangalia hii angle opposite yake ni distance from where the image will be formed mpaka kwenye central ambayo ni x. Okay? And the adjacent yake ni kutoka from where the slit is mpaka the screen ambayo ni D. Okay? Kutoka kwenye where the screen mpaka D. So inakuwa hivyo ukiexpress in terms of tan, you can see kwamba tan ni opposite over adjacent, so you can see clearly tan theta from this diagram ni sawa na x over d. Okay, tan theta ni sawa na x over d. Take that into your mind, tutaitumia hapo mbele kidogo. So just like kwenye interference where we spoke of bright fringes and dark fringes, you remember kwenye statement ambayo niliweka note, so tulisema kwamba when we have a whole number of wavelengths tunapata a bright fringe ambayo kwenye mabano niliweka ilikuwa ni maxima. Okay, tukiwa na odd number of half wavelengths, tukiwa na odd number of half wavelengths, nilisema tutakuwa na minima or the dark fringe. But you can see here kama ilivyo kwenye air wedge, kama ilivyo kwenye Newton's rings, inakuwa inverse. Okay, ni tofauti na kwenye Young's double slit experiment. Young's double slit ndio ina obey what I have said, but for kama ilivyo kwenye air wedge, kama ilivyo kwenye Newton's rings, similarly hapa kwenye diffraction na kwenye Fresnel's by prism, nakumbuka au Lyot's mirror test walikuwa wana obey the inverse of it. So tunakuwa na minima or dark fringe kwenye whole number of wavelengths. As you can see, d sin theta ni sawa na plus or minus n, plus or minus because for this case the image can be formed, as you can see here, image can be formed above or below the center O. We shall see that center O kwa huku ina terminology special. So when n is equal to 1 2 3, you can see n is equal to 1 2 3, so n wavelength inakuwa ni a whole number of wavelengths. So for this case, kama ilivyo kwenye hizo tatu cases ambazo nimewambia, air wedge, Newton's rings na Lyot's mirror, all number of wavelengths tunapata minima or dark fringe kwa namna nyingine kule kwenye interference. So kwa this case ni minima. Okay, we shall be using terms of minima and maxima. So when you have whole number of wavelengths tunakuwa na minima. but when you have odd number of half wavelengths, as you can see hapa, from, you remember nilikwambia this one you can express it whatever way you want, okay, as long as you correctly define n yako inaanzia ngapi, okay, as long as you correctly define n yako inaanzia ngapi. So for this case, plus or minus 2n plus 1, okay, for values za n is equal to 0, 1, 2, 3 na kuendelea. You can see when n is equal to 1, 2 inakuwa hapa ni 2 plus 1 inakuwa ni 3, so inakuwa 3 over 2 wavelengths, so ni 3 half wavelengths. When 2 is put there inakuwa ni 4 plus 1 inakuwa ni 5 half wavelengths. When you put 3 inakuwa ni 6 plus 1 ni 7 half wavelengths. So you can see inakuwa ni odd number of half wavelengths. So unlike kwenye double slits, huku kwenye odd number of half wavelengths kama ilivyo kwenye average Newton's rings na Rayleigh's mirror, tunapata maxima or bright fringe kama ingekuwa ni kwenye interference. I told you the other time kwamba you can put this in whatever way. You remember na nakazia kwamba different books have written different formulas. The most important thing ni ukisubstitute values zako za n zilete the same meaning, okay, kama tulivyosema awali kwenye interference, if you can recall. However, tuna kitu tunaita central maximum, ambayo ndio hii center O. For this case tunaita central maximum, okay, it is the point kwenye screen when n is equal to 0, okay, when n is equal to 0, okay, kwa kutumia formula ya minima, that point itakuwa ni central maximum when n is equal to 0. You can see when you put it, n is the point where no image is formed, okay, the point where there is no diffraction, okay, there is no diffraction. So we know our n inaanzia 1 tu na kuendelea for diffraction to occur ya minima, okay, but if you put n is equal to 0 it means umetengeneza kitu ambacho hakipo. So that's why we are putting it ili kulocate point ambayo kutakuwa na no diffraction. So if you put n is equal to 0, you shall see kwamba hapa utapata sin theta ni sawa sana 0, because you put n 0 times wavelength ni 0. Ukileta d huku 0 divided by d itakuwa ni 0, so tabaki na sin theta ni sawa na 0. So theta utaona ni sawa sana 0 degrees. So sin 0 degrees ndio huwa ni 0, okay, so that means hapa kunakuwa hamna angle, ni 0 degrees. So it means hii imecollapse, imeshuka mpaka imekuja kwenye point O. So it's a point where there is no diffraction. So light rays zimepita moja kwa moja zitaenda ku strike kwenye the center O. That's the point we call it central maximum, okay, central maximum. So we have a note here, it's just an addition kwamba we have maximum order. When we speak of order tunamaanisha hizo n values za n. So we have maximum order when theta is equal to 90. Remember kuna maswali ambayo utaambiwa how many, kwa sababu tunavyosema n is equal to 1 it means the first kama ni secondary max minima, for example kama ni secondary minima, n is equal to 1 means the first image ambayo itakuwa ni first secondary minima. 2 ni second image ambayo ni second secondary minima. So when we put the angle 90, value ya n tutakaopata ni maximum number of images that can be formed for a particular wavelength and a particular width ya slit d, okay. So for a given wavelength and for a given the width of the slit d, when we put sin the angle tukaweka 90 tutapata n, which is will be the maximum order or the maximum number of image that can be formed. Kwamba beyond that you cannot form image with the conditions hizo za wavelength na d unless we change the width of the slits d or we change the wavelength of the light we are using. So that for that case n inakuwa sawa na d, because also sin 90 ni 1, so tunabaki na wavelength na d, okay, tunabaki na d over wavelength. So tukichukua hii formula d over wavelength tutapata number of maximum image that can be formed. So here we have a terminology called linear width of central maximum. Tumeshasema central maximum ni point O. So width yake tukisema linear width of central maximum huwa tunamaanisha distance between the first secondary minimum and on either side of the central maximum, okay, on either side of the central maximum. This is just a terminology. Usishangae tulitumia formula ya secondary minima ili kuderive that formula, okay, it doesn't matter, we just used that formula for simplicity. You can see kuna halves we complicate the issue. So we use that formula to simplify matters, and so that point is called the central maximum. It's just a terminology, okay, that we had to name this point, so we decided to name it central maximum. So speaking of the width, linear width, okay, linear width, kumbuka tunaongelea this distance. Hii ndio linear width. Hii ni angular width. Hii ni angular width. Okay? So tunapoongelea linear width of central maximum is there. So is the distance between the first image that will be formed on either side. So kama first image itakuwa formed hapo na itakuwa formed huku, the total distance from the upper image to the lower image, hiyo ndio width ya central maximum yetu, kwamba how large the central maximum will become. So as you can see, all this area will not be covered by any image. Images will be formed beyond your width here, central maximum. So is the distance between the first secondary minimum. Okay, the distance between the first, remember ni secondary minimum for simplicity of calculations, tunatumia the minimum. Okay, as you remember, tulitumia the same formula to get the point, the central maximum. So if we decided to create an expression ya kucalculate linear width ya central maximum, kama tungeamua kutafuta hiyo expression yake, so we know kabisa kwamba sin theta ni sawa na wavelength over d. Okay, wavelength over d, n is equal to 1 kwa sababu tumesema ni first secondary minimum. Okay, n is equal to 1, so putting n is equal to 1 tunakuwa na sin theta ni sawa na wavelength over d. From here, when n is equal to 1, sin theta inakuwa ni sawa na wavelength over d, wavelength over d. However, if the angle is very small, we don't expect these angles to be very very huge. If the angle is small, mathematical principles zinatuambia kwamba sin theta will almost be equal to theta in radians. Okay, will almost be equal to theta in radians. Hii ni math too, simple trigonometry, kwamba sin theta, if the angle is very small, value of sin theta is sana almost equal to theta. You can try on your calculator, sin ya 0.0001 ni sawa na angle hiyo 0.001 ikiwa in radians. Okay, ambayo itafanana pia ukichukua tan ya ile angle the same. So sin theta inakuwa almost equal to the angle in radians, which is almost equal to its value of tan too. Okay, but we know, as I said, nilikwambia saa zile, keep that formula, we use it ahead. Ndio hapa tunakumbuka tulisema tan theta ni sawa na x over d. The angle is here theta, okay, and the opposite is x. Okay, the opposite is x, and then adjacent is d kubwa, distance from the screen to the slits. So inakuwa sawa na x over d. So x over d, okay, x over d ni sawa, kumbuka tan theta tulisema ni sawa na sin theta, ambao sin theta tulishasema ni sawa na wavelength over d. So it means x over d ni sawa na wavelength over d, because tan theta is almost equal to sin theta. We can approximate, say that wavelength over d ni sawa na x over d. Wavelength over d ni sawa na x over d kubwa. Remember to differentiate the two. This is width of slit, this is distance from the slits to the screen. Okay, so we know from here kwamba x, from here x itakuwa ni sawa na x itakuwa ni sawa na d, itakuwa sawa na d times wavelength over d ndogo. But we know that the distance, the linear width we are speaking, ni either side of the central maximum. So it means kama x ni distance from the central maximum to the first maximum on one side, so the total width itakuwa ni twice this, so 2x. Remember x tulisema nini? Ni d wavelength over d, so it means ni twice d wavelength over d. So speaking of 2 distance times distance from the slits to the screen times wavelength divided by the width of the slits, tunapata this is the linear width. This is the linear width of our central maximum. Okay, this is the linear width. So linear width is given by 2 d kubwa times wavelength over d ndogo, as you can see stated hapo. However, for angular width we can go back kwamba sin theta tumesema ni wavelength over d, tayari tuna sin theta, but remember on either side it means ni twice hiyo angle. So 2 times theta ni sawa na 2 times wavelength over d ndogo. So again, these two as the formulas, for the linear width of the central maximum. Linear width of the central maximum. This is the linear width and this is the angular width. Okay, so as you can see, formulas zinafanana interference. Okay, it is because practically na scientifically the two phenomena zinaweza zikawa zinafanana, yani sometimes people confuse them kwamba zinakuwa zina similar characteristics. So we shall hereby see the difference between interference and diffraction. They are similar yet they are different. Okay, they are similar yet they are different. So interference, cha kwanza, interference is due to superposition of light waves coming from two coherent sources. You remember that one among the conditions that form interference was that light has to come from different coherent sources, two coherent sources. But diffraction is a superposition of secondary wavelets coming from different parts of the same wavefront. As you can see, the same wavefront ikija hapa inakuwa diffracted in a spread. As you can see earlier tulionyesha wavefront manake nini, wavelets manake nini. So superposition of the secondary wavelets coming from different points among the same wavefront. Okay, the same wavefront, lakini superposition of the secondary wavelets sasa zile ambazo zinatoka kwenye the same wavefront ndio zina form diffraction. So hii inatoka kwenye coherent sources, hii ni ile wavefront, lakini inatengeneza wavelets ambazo zinatengeneza diffraction. Kwenye interference, all bright fringes have the same intensity, kwamba ukiwa na bright fringe ya kwanza, bright fringe ya pili, bright fringe ya tatu zinakuwa zina the same intensity. Okay, ile strength ya image inakuwa the same, while this one decreases the number of fringes. So unavozidi kwenda higher number of fringes, intensity inakuwa ina decrease, ile strength ya ile image unayopata. And for interference, width of interference fringes may or may not be the same. Okay, may or may not be the same. So there is a possibility that the width of interference fringes maybe somehow they might collide and zikawa zinafanana the width ya fringe. However, for diffraction they are never having the same width. Diffraction fringe never have the same width. They never. But for this, they may or may not be the same. Interference, dark fringes are almost perfectly black. Okay, dark fringe. When you speak of a dark fringe, you are speaking of a very dark fringe. They are almost perfectly dark. So perfect, almost perfectly dark. While for diffraction, the dark fringes are not perfectly dark. They might not be, the darkness might not be so intense. Okay, again we can see the difference. You see diffraction hapa tumetumia mfano wa single slit, but you can have multiple slits. Okay, diffraction inaweza ikatokea kama your slits ukaarrange different slits, still diffraction inaweza ikatokea. So here we have distribution pattern. Okay, the graph of intensity against the distance. Okay, the graph against intensity and the distance, intensity versus distance from the central maximum. Okay, so with the increased number of slits. So tukiwa na two slits, this is the pattern. Tukiwa na three slits, they like to ask this. Okay, sketch the intensity pattern for two slits, sketch the intensity pattern for three slits, for six slits, etc. One thing to note is that here we have principal maximum, which are these big peaks. Okay, let me use this example ili tuone vyote. So we have principal maximum and we have subsidiary maximum. Okay, ni kama masomo yetu PCB na GS na BAM, au PCM, GS na BAM. PCM au B zinakuwa ni principal subjects, BAM na nini zinakuwa ni subsidiary, inakuwa na importance kidogo. Hata kwenye combination yetu you can see they don't consider them sana kwenye division. So the same inakuwa hapa, the principal subjects zinakuwa zina higher peaks while the subsidiary maxima zinakuwa zina lower peaks, kwa sababu umuhimu wake ni mdogo. I don't say you should ignore your subjects, no, you shall face the consequences. Because competition ni kubwa, you have to study both ili ufaulu vizuri zote. Kama unaweza, hamna sababu ya kufeli kwa sababu tu ni sio la muhimu, faulu yote. Okay, so this is the principal maximum, this is the subsidiary maximum. So you can see if you want to sketch kujua number of subsidiary maximum ni sawa sana number of slits minus 2. Okay, number of slits minus 2 unapata number of the subsidiary maximum. So for 2 slits 2 minus 2 ni 0, hamna subsidiary maximum as you can see. While for 3 slits 3 minus 2 inakuwa ni 1. So after every principal maximum we always start with the principal maximum at the center. Okay, so there is always a subsidiary maximum after every principal maximum. While for 6 slits 6 minus 2 is 4, so there are always 4 subsidiary maxima after every principal maxima. You can see principal maxima and 4 subsidiary maxima, principal maxima and 4 subsidiary maxima. For 10 slits likewise 10 minus 2 is 8. You can see there are 8 subsidiary maximums between the principal maximum, just like that.